Hello, welcome to this video on piecewise functions. So piecewise functions are where we put together different pieces of a graph to define a function. And you will often see a little curly bracket in the definition of the function. Our function's not going to be equal to just one expression. Here we have f of x equals, we've got the curly bracket, we've got three different cases. Our function is equal to x squared if x is less than 0. It's equal to -2 if x is equal to 0, and is equal to 3x plus 4 if x is greater than 0. So if we were going to look at this on a graph, what we're going to see is to the left of 0, our function is going to look like the x squared graph. So it's going to look like the left half of a parabola. When x is equal to 0, it's going to be at a y value of -2. And I'm not going to worry about drawing this to scale, just to give you guys an idea what this is look like. And then if x is greater than 0, it's going to look like the line 3x plus 4. Well, that's going to have a y-intercept at 4 and then have a positive slope. And because these are strictly less than and strictly greater than, we will have open circles on our graph as those get closer to 0, and then our closed circle is going to be down here where x equals 0 and y equal -2. So this was just to kind of give you an idea of what a piecewise function graph looks like. You just graph each of those pieces on their respective domains. All right, so the first step whenever you're evaluating one of these piecewise functions is to figure out which of the categories given in our function, as far as our domain, our x values, we're looking at. So if we wanted to find f of -2, well, f of -2 is, of course, less than 0. So that means that we will only be looking at that top line. We can completely ignore the rest of the function. And so, just like if we had regular function notation with a non-piecewise function, we would just plug in whatever we have in the parentheses here for every x in our function. That's going to be -2 squared. And so we get 4. And what it's telling us is this point here at -2 is going to be at y equal 4. Do the same thing for f of 0. F of 0, of course, is equal to 0, and so our y value is -2, and that's the point that we have graphed on that y-axis there. And then our last one, we're looking at f of 1. Well, f of 1 is bigger than 0, so that means we're only looking at that bottom category, and we get 3 times 1 plus 4 gives us a y value of 7, and that's going to be this point up here. My line should be over here, should be a little more steep, but we're going to say that's the 0.37. All right, another example, we have f of x is 3x minus 1 if our x is in the range where -3 is less than or equal to x is less than or equal to 2. And it is equal to x cubed minus 2 if our x is in the range such that 2 is less than x is less than or equal to 6. Our first problem that we're looking for, our first function value, is f of 0. 0 is between -3 and 2, and so that means we're going to be in this first category. We can completely ignore the second one, and we'll get 3 times 0 minus 1 gives us a y value of -1. If we wanted to find f of 1, well, 1 is still between -3 and 2, so it's going to still be in that same category. And so we're going to plug in to the same expression. 3 times our x value of 1 minus 1 gives us a y value of 2. If we wanted to find f of 2, well, 2 is in that range because x is less than or equal to 2. So that means f of 2 would still be on that top expression. So we get 3 times 2 minus 1, which is 5. Because this one right here is a strictly less than, 2 is strictly less than x. And so the only one from this example that's in that bottom category is our 6, because we're finding f of 6. And so now we'll only look at the bottom one, and we get 6 cubed minus 2. And 6 cubed is 216, minus 2 is 214. All right, I'll see you guys next time.